Good morning. Welcome to the Artist Math IG Live. Today, we're going to talk a little bit about surface area and a little bit about volume of rectangular prisms. All right. So this is the problem that I want to cover today. This gets us into our geometry and our measurement. So first, as always, you see, this is a slight word problem. Okay. So you want to read the word problem and understand it. All right. You might need to read it a couple times to gain full understanding of the word problem. And that's fine. That's just part of the process sometimes. So it says that the surface area of this rectangular prism, this is a rectangular prism. All a rectangular prism is like, think of it like a cardboard box that when you might order something online, something comes in the mail, it might come in a cardboard box shaped like this. No biggie, All right. So the surface area of this rectangular prism is 102 inches squared. And of course, area is always in square units. Volume is in cubic units. Area is in square units. So that's why we have the little exponent 2 above the unit for inches. Find the volume. So that is our goal. Our goal is to find the volume. Find the volume of what, though? Of this rectangular prism. All right. So because the volume is important, I'm going to underline that. And I'm also going to underline surface area, because that's important too. Now, I know what the surface area is, but let's talk about what surface area actually represents. The surface area is the area of all the faces or the outside spaces on this box. Think of a rectangular prism as a box. All right. Now, it's got a front side, a right side, it's got a left side that you can't see on this picture. It's got a top, it's got a bottom, and it's got a back. If you take the area of each of these surfaces and you add them all up, the total surface area will be 102 square inches. All right. Now, what we want to find is the volume. The volume represents a different type of measurement. The volume is the amount of space inside the box. And the volume is important because that enables us to know, well, how much stuff can I fit inside this particular box? Because if I was shipping something, let's say I had an online business and I'm shipping things out to people, I need to make sure that the type of box or package that I buy, right, will be able to fit all of my merchandise in it. All right. So unless that work is already done for you, you might have to do some calculations on your own sometime, right? So surface area we know, we don't know the volume. So since we want to find the volume, let's talk about a formula. The formula for the volume of any rectangular prism is this. You always want to write your formulas down. V equals L times W times H. Now, of course, V stands for volume, but we need to know what L, W, and H stand for. L stands for the length of the rectangular prism. W stands for the width of the rectangular prism. H stands for the height of the rectangular prism. Now, sometimes it really doesn't matter what numbers go in these spaces, right? Now, what do I mean by that? I mean, based upon the way that I drew this rectangular prism, I could say that the width was 3 inches because that's how wide it looks to me, horizontally. I could say that the length was 2 inches because going back, I could look at it like that. I could say that the height is this dimension right here that we don't know, right? But what if I had drawn this rectangular prism line on the side like this, or line down flat? Then that would change the orientation. And then we could have different numbers for L, W, and H, right? But the key is, as long as we multiply all three of those dimensions together, we'll get the same number for the volume. But let's deal with this based on how it's drawn right here on this board. So what I'm going to say is, I'm going to label the information that I know. I'm going to say, okay, well, my width is 3 inches. So I'm going to say W equals 3. And I'm going to say my length is 2 inches. So I'm going to say L is equal to 2. Now, I also need height, right, in order to calculate the volume. But of course, that would be too easy. If they just gave us the height, then we'd be done. You know what I mean? We just multiply the 3 times the 2 times whatever height is, and we'd be done. But of course, this problem can't be that simple, right? So the height is unknown, all right? Because the height is this dimension. Right? From here to here. from the bottom to the top, from the top to the bottom. That's the height, right? Now, because we don't know the height, we need to figure out what the height is. Because we can't figure out the volume without knowing what the height is. So now let's look at the other information that we were given in this problem. We were given that the surface area is 102 square inches. So that should get you thinking. Why would they give you the surface area if we were not meant to use it? Usually in problems, they don't give us, superfluous or extraneous information. Sometimes they do to try to throw us off. But in many cases, they will not give us information unless we can actually use it. So let's think about this. What is the formula for the surface area of a rectangular prism? Let's write this down. Surface area is equal to, and I don't have this formula memorized, just to keep it 100 with you. I don't have this formula memorized, but that's cool because I have it written down on my paper, right? So if you ever don't have a formula memorized, like I had the formula for volume memorized, if you have a formula written down on your paper in a neat and organized way, and you can refer to it, that's just as good. All right? So surface area of a rectangular prism is equal to 2 times the quantity, length times width, plus length times height. And I hope I don't confuse you because up here I use X's for multiplication, and down here I'm using dots for multiplication. I just switched up on you, right? But we're going to get the same answer. It's cool, right? Anyway, length times width plus length times height plus width times height. All right? Now, the reason I'm going to use this is because, again, I know what the surface area is. Boom. So that's going to go right there. This is just a 2. I know the length. So where these L's are, I'm going to put a 2. I'm going to put 2's where the L's are. I know what the width is. So wherever I see a W, I'm going to replace that with a 3. Put a 3 here and a 3 here. And then for the height, that's what I don't know. But I can solve for that. Because in that equation, because this formula essentially is just an equation. That's all this formula is. This formula is an equation. And in any equation, if we have one variable, we can solve for that one variable if we know everything else. And in this case, I know everything else. I know what the surface area is. It's 102. How do I know that? They gave it to us in the original problem. That's given information, right? This is a 2. I know what L is. L is 2 inches because that's given information. W is 3 inches. That's given information. The only thing I don't know is the height. And it doesn't matter that the height is listed 2 times. That's one variable, right? And we're going to combine those by combining like terms, which is something that we always do in algebra, right? So now, let's fill in for everything that we know. So I know what the surface area is. So I'm going to replace that with 102. I write the equal sign. And if I'm not replacing something, I just copy it over. All right. So this equal sign is not being replaced. This 2 is not being replaced. This parenthesis is not being replaced. This L is being replaced because I know what L is. The purpose of variables is to represent an unknown value. Now, once I know what the value is, I don't need the variable no more. So those of you that say, I don't like algebra because of the letters, or math was cool until we got to algebra and they started talking about letters. That's cool. Once you know what the numbers are, you don't need the letters no more. So we can get rid of the letters. So wherever I see an L, I replace it with a 2. Multiplication sign comes down. Wherever I see a W, I replace it with a 3. All right. Wherever I see this plus sign, bring that down. I see another L. What was L? L was 2. L is still 2. Multiplication sign. Okay, boom. Yeah, I got an H right here. That represents the height. That's what we don't know. So we got to copy that H. Plus sign. W. Again. W is 3. Times H. We don't know H. All right. So now we got everything replaced. We got our letters replaced. And now we have as many numbers as we can. We still have some letters or variables, technically speaking. The technical term is variables, right? But if you feel more comfortable with using the word letter or just referring to these as letters, that's cool too, as long as we get to the correct answer. All right. So we got H and we got H. Now we need to basically clean this up, simplify it into a nice, neat, concise equation, and then solve for H. That's our goal. Because why? You always know why you're doing what you're doing, right? We're solving for H because once we solve for H, we'll be able to then solve for the volume. Because the only reason we couldn't solve for the volume in the first place was because we didn't know what the height was. We didn't know what h was. We know what L and W are, but we don't know what h are. Once we know what h is, that's the last piece of the puzzle. And then we just multiply L, W, and h, and we're going to be done. Because the original problem says to find the volume. All right? So essentially, in a lot of these problems, this being one of them, you have to use what you got to get what you want, right? We got this and this. We want this. And then ultimately, we want that. So we're going to use what we got to get what we want, which is the volume. All right? So let's get back to the math. All right. So inside the parentheses, remember, we always use order of operations. We use all those different types of rules that we learned a long time ago. All right? Or those fundamentals that you might be learning right now. And that's cool too. So I'm going to bring down the 102. I'm going to bring down the equal sign. I'm going to bring this 2 down. And then in the parentheses, I got 2 times 3, which is 6. And then, so I'm going to simplify that, make that a 6. Then I got, in here, I got 2 times h. A number times a letter is just that number and letter juxtaposed right next to each other. So 2 times h is just 2h. And then 3 times h is just 3h. All right? So now, we're simplifying this, getting more concise, right? Now, I see like terms inside the parentheses. There's 2h and there's 3h. I'm going to combine them. 2 h's plus 3 h's is a total of 5 h's. All right? So that's going to be 5h. So I bring this down. I got 102 equals 2 times the quantity, 6 plus 5h. And you see how, like, on your paper, you want to do math problems like this in a nice, consistent, neat, organized manner. Step 1, step 2, step 3, step 4. So you can go back and do yourself this favor. So you can go back and be able to see what you did. Okay, if you say, well, Dad, what happened to the 2 and the 3? Oh, it became a 6. Oh, where does 2h come from? Oh, 2 times h. Oh, where does 3h come from? Oh, 3 times h. Where did 5h come from? Up here, the previous step, I had 2h plus 3h, and 2 plus 3 is 5. So therefore, 2h plus 3h is 5h. All right, so now, I can't combine these two because they're not like terms. That's a plain number. That's an integer. That's 6. This is a variable, right? This is 5 h's. We can't add those together. We could multiply or divide them, but we cannot add or subtract them, right? We can only add or subtract like terms. These are not like terms. This has a letter in it. This does not. Letter, no letter. No letter, letter. They're not like terms, so we cannot add them. This does not equal up to 11h. It does not. Remember that. Write it down. Take a picture. This does not add up to 11h. Keep that in mind. But what we can do is distribute, because we got a 2 outside of the parentheses. Distribute meaning I could give this 2 to the 6, and I could give this 2 to the 5h, right? And then I'm going to bring down my 102 out here, and I'm going to say 2 times 6. That gives me 12. And then I'm going to say 10h, because 2 times 5h is 10h. Notice what I said. You cannot add unlike terms, but you can multiply them. 2 and 5h are not like terms. But with multiplication, it's cool. You can multiply or divide them together, but you can't add or subtract them. Keep that in mind. All right? You can, with unlike terms, I should say, you can multiply and divide them, but you can't add and subtract them. Remember that. So that's why I was able to do 2 times 5h, which gives us 10h. Now, this is my equation now. 102. See, it's getting smaller and smaller. It's shrinking. It's shrinking. 102 equals 12 plus 10h. So now what I got is, I want to get 10h by itself because I'm trying to solve for h at the end of the day, right? So I got to get rid of this 12. This is a positive 12. So I get rid of a positive 12 by subtracting 12. So I'm going to do minus 12 on the right side, and I'm going to keep everything balanced. I'm not going to do minus 12 right here because I can't do that anyway because that wouldn't be like terms. But I'm going to do minus 12 on the other side of the equation. I'm going to slide over to the left side. Now, 12 minus 12 is nothing. 102 minus 12 is going to be what? 90? Just like if you had $102 and you spent $12, you should have $90 left. Unless somebody robs you and give you your correct change. Don't let that happen. All right? So we bring the 10h down, right? But I'm going to slide it over here closer to the equal sign. Now I'm trying to solve for h. So I need to get rid of this 10, right? Yeah, I need to get rid of this 10. This is 10 times h. That's what that means. So we need to do the opposite operation. The opposite of multiplying is dividing. So I'm going to divide this by 10, and I'm going to divide this by 10. 10 divided by 10 is 1, so I got 1h. 1h, which is just h. And then 90 divided by 10 is 9. So now I know what, that's not my final answer. Don't get it confused. H is not the final answer. We're trying to find the volume. We need H to find the volume. So this is what's going to happen. I'm going to switch up the color. All right? This is what we're going to happen. All right? So I'm going to do L times W times H. So what's my L? It's still 2 inches. Boom. What's my W? It's still 3 inches. What's my H? I just figured that out. It's 9 inches. That seems reasonable too, right? Because if we're looking at a box that's drawn like this, if this was 3 inches horizontally, 2 inches lengthwise, going to the back, and then the vertical distance, or vertical length from the bottom to the top, that seems reasonable, right? Even though all figures and diagrams are not going to be drawn to scale, meaning they're not going to represent the actual relationship between the sides, right? This looks reasonable. All right, so we got 2 times 3 times 9. Now, 2 times 3 is 6. 6 times 9 is 54. And don't forget your units. We're dealing with inches. But area is squared. But what is volume, though? Volume is to the 3rd power, or cubed. So surface area is squared. That's why it's 102 inches squared. But volume is cubed. So don't leave that out. Don't leave that exponent 3 out. Because you might have a teacher that's like real particular about that, like me. Might take a couple points off your paper, even though you did all this beautiful work to get to 54. But if your units are not correct, you're going to lose a couple points because you're not paying attention to detail. All right? So always remember that volume is units to the 3rd power. Area is units to the 2nd power. And that means that the volume of this box or this rectangular prism is 54 cubic inches. All right? So that does it for today's session on surface area and volume. And as you see, this is a geometry topic, but we had to use algebra, right? We cannot get away from the algebra. The algebra is very necessary. All right. I hope you learned something. Thanks for tuning in. And if you have any further questions, please do not hesitate to send a DM with a picture of your math problems to the All This Math DM. Peace.